Hey everyone, welcome back to the channel Code with AKJ. Today is day 9 of solving LeetCode 75 challenge, and today's question is string compression, which is a medium level question. So the question says here, given an array of characters chars, compress it using the following algorithm. And the algorithm says begin with an empty string s. For each group of consecutive repeating characters in chars, if the group's length is 1, append the character to s. Otherwise, append the character followed by the group's length. So the compressed string s should not be returned separately, but instead be stored in the input character array chars. Note that the group lengths that are 10 or longer will be split into multiple characters in chars. After you are done modifying the input array, return the new length of the array. You must write an algorithm that uses only constant extra space. So here we are given an array of characters and we need to compress it by grouping consecutive repeating characters. And for each group, if the length is 1, we just keep the character. And if it's more than 1, we add the character followed by the count of its group length. So here one catch is that we need to do that in place, and meaning we can't use any extra space other than a constant amount. So let's look at an example here. Given chars array, the groups are AA, BB, CCC. And since the group's length is more than 1, so here we need to mention the character first and the length of its group. So our output here would be A followed by its group length, which is 2, and same goes with B with its group's length 2, and the C with its group length 3. So here a simple brute force way would be to iterate over this each character and count the consecutive duplicates and then create a new list to store the compressed version. So in the brute force approach, we'll build a separate string to store the compressed version and then update chars based on that compressed string. However, note that this particular approach does not satisfy the problem requirement of using only extra constant space, but still let's see our brute force approach and try to submit this question. So here's the brute force approach code where I have taken an external string compressed which is initially empty. I have taken the size of our chars array. I have iterated over this chars vector and accessed each current char, and initially our count variable would be 1, and this while loop is for counting consecutive repeating characters, grouping all duplicate characters into a single group, and along with that also incrementing our count variable to check the group's length. And finally, since our answer and our compressed string contains character first and followed by its group's length, I've added the character first into our compressed string, and after that I have checked whether the count variable is greater than 1 or not. If it is, then we'll add that count variable into our compressed string. So before adding it, I have to convert the integer data type to string data type, and we can do that by using toString function. In this way, we have converted our integer data type to string data type, and I have added that value into our compressed string. So after doing this whole for loop, I have updated the chars array in place by iterating over our compressed string. Since our problem statement asks us to return the size of that compressed string, we have returned the compressed dot size value. So let's run this code. So let's submit. As you can see, this approach gets accepted, but the brute force solution here takes O of n time complexity, as we are iterating over our chars array and creating our group and converting that count to string and building our compressed string. And coming to the space complexity, since we use a separate string compressed to store the result, the space complexity is O of n, which is not optimal as it doesn't meet the constant extra space requirement in our problem statement. So for our optimal solution, we'll use a two-pointer approach with an in-place modification of our character array. So here we'll use one pointer to keep track of where to insert characters and another to iterate over our chars array. So let's initialize a right pointer to 0, and this will point to the position in the array where we should write the compressed result. And then we'll use a read pointer to traverse through each character in chars. And for each character group, we count the number of consecutive duplicates using a loop. And finally, we'll write the character at the right pointer. And if the count variable is greater than 1, we write each digit of the count as characters in our chars array. So this is our optimal approach, and let's move on to our code and then let's do a dry run using this example. And finally, we'll move on to our time complexity and space complexity analysis. And in summary, we'll try to compare both brute force approach and optimal approach, time complexity and space complexity. So here's the code for the optimal approach. Here I've taken both pointers write and read. Write is a pointer for writing the compressed result in place, and read pointer is for reading characters from the original array. Here I've taken the while loop which runs over our chars vector. I've taken each char value and a count variable which is 0, and I've checked for consecutive characters which forms a group, and incremented our read pointer and count variable. And since our answer should be in the form of character followed by its length of its group, we have first added our character value using a right pointer in our original chars vector. And finally, coming to the count variable, if the count variable is greater than 1, we have written each digit of count into our original chars vector using our right pointer. And finally, I have written the right pointer which points at the end of the array, which finally returns our size of the chars vector. So let's run this code. So again, so let's submit. As you can see, this problem gets accepted. And coming to the time complexity and space complexity, so this solution has a time complexity of O of n since we have only iterating through chars once, and the space complexity here is O of 1 as we are not using any external string or any data structure to store our answer. So let's try to dry run this approach using this example. So let's try to dry run with this example. So here our read pointer would start from index 0. We try to check whether the current character is equal to the strings read pointers character, which is A. So since they are both are equal, here initial the count value becomes 1. We'll move our read pointer to the next index. We'll again check the characters are same or not. So since both are same, we'll increment our count value from 1 to 2, and we'll move our read pointer to the next value. So since they both are not equal, we'll try to update our vector of chars using our right pointer. So since right pointer is 0, so first index would be updated with our character which is A, followed by the count variable. So here we'll check whether the count is greater than 1 or not. So if it is 1, we'll update our second index value with our count variable which is 2, but it is in integer format, so we'll try to convert this integer into a string using toString function. So the vector of chars would be updated with the value 2, which is in the string format. So same goes with the second group which is BB. So the third index of our vector would be updated with the character B followed by its group length 2. Same goes with the third group which is C, whose count is 3. So the index would be updated with the character C followed by its group length 3. So in this way, by moving our right pointers from one index to another index, finally our right pointer would be pointing to the end size of our vector, and finally the vector size would be our right pointer's pointing index, which is 6. So in this case our answer would be 6. So this is how our optimal approach works. So coming to the analysis of both brute force approach and optimal approach. So brute force approach time complexity is O of n and space complexity is O of n, and whereas in our optimal approach the time complexity here is O of n and space complexity here is O of 1, meeting our need of using only constant space. So in this way we have optimized our space complexity from O of n to O of 1, making it much more efficient for larger inputs. And there are few more edge cases. So if chars has only one character, that is a single character which is A, the output remains A with a length of 1. And another edge case here would be if all characters are unique, that is A, B and C, array stays the same and the length here returned is just the length of the chars, which is 3. And the third edge case here would be if the chars has large groups, for example, length of 10 with with 9 A's, and last character would be a single B. Here the count 10 will be stored as the separate characters 1 and 0. So this would be the three edge cases we need to handle in this problem statement. And that's it. We have covered a brute force approach and optimized it to an efficient in-place solution for this string compression problem. So if you found this helpful, don't forget to like and subscribe for more coding challenges. And let me know in the comments what problem you'd like me to solve next. Thank you, and I'll see you in the next one.